Hi, everyone, and welcome to this week's Springboard Office Hours for Data Science. This week, we have a very special guest. We have Rajiv, who is a mentor at Springboard. This is our career office hour, so this is your chance to hear us discuss data science, but also, of course, ask him all kinds of questions about his career as a data scientist. Rajiv is a data scientist at Caterpillar and was previously at State Farm. He is also an adjunct professor at the University of Illinois at Chicago. His background includes a bachelor's in electrical engineering and a PhD in communications from the University of Illinois. He loves tackling interesting problems and has worked on a variety of projects studying crime, basketball, auto crashes, and security issues. So let's all give a virtual welcome to Rajiv. The way that this session will work is this goes for 60 minutes. Whenever you have a question, go ahead and type it into the chat at the right-hand side of the screen. And we'll usually go about it that way. You can also sometimes raise your hand as well, and we'll stop and give you a chance. We'll stop when appropriate and give you a chance to ask a question and whatnot. So go ahead and start typing in questions. We'll answer as many as we can. We'll probably get with this group. We'll probably be able to get through all of them. But don't be shy. I have a list of questions that I'll ask, as well as questions that come up organically. So don't be shy, to jump in as well. My name is Ryan Rosario. I am a data science mentor with the intensive class, also the career track, and the host for this office hours in case you haven't been here before. So we'll go ahead and get started, and feel free to type in your questions. So tell me a little bit about why you chose a career in data science.
So I started my career in data science before there was data science, so to speak. So it's probably easier to just kind of show you how I kind of meandered and ended up in data science. My undergraduate was in engineering. I liked computers. I liked technology. I went and got a degree there. But after I finished and got that degree, I was just like, I want to do something else. I just didn't want to be an engineer. And so I kind of ended up at the University of Illinois, and I got a PhD in communications. And there I kind of worked on kind of social science research projects, but they were structured around the internet. So I was able to kind of use my technical background, but then solve kind of interesting policy-related problems like around privacy and free speech with the internet. Because at the time, the internet was like a new hot thing. And so there was a lot of interest in doing this. And so, when I was in social science research, you have to take classes in qualitative methodology. And so I learned qualitative techniques for answering questions as well as quantitative. And so I had to have, kind of the basic statistics classes as well. And so, my background has those statistics classes as well as kind of the advanced math from when I was in engineering. And I like doing social science research. And I did, various ones, maybe like I did one on Wi-Fi access points where people like drove around with little devices mapping out Wi-Fi access points. And we had databases of over like 1 million Wi-Fi access points, which we at the time thought was a really big database, right, that we were kind of working with and having to deal with. There I also had kind of qualitative studies. I did that for a while. And then kind of around 2010, I switched out and I kind of had to kind of switch careers. My family life changed. And so I left academia, but at the time I was a social science researcher. I was like, kind of a sociologist that knew technology really well. I looked in the want ads and there was ads for statisticians, for example, but, I wasn't really a statistician. I hadn't trained, for 4 years or 6 years doing that. But then there was ads for computer stuff, right? There's always a demand for IT. And so I was like, I'll go in IT. And I was I worked at a university here, Illinois State University, as a system administrator. But after about a year or so, I missed kind of doing research. I missed doing the teaching that I had done before, kind of do it on my PhD, and then I worked for a number of years as a professor. And so I kind of got back into it, and kind of the world had changed a little bit in those few years. And for example, R was a big deal at this point. And so I started taking time, and I kind of started to learn R for the projects because I wanted to do that. I wanted to use that. Like Shiny had just come out. Like I used one of the earliest releases of Shiny because I was like, man, this is cool. I can make these kind of nice web apps this way to show my data. And so, but then along the way, I kind of ran into this field, data science, and I saw they're hiring, right? There's lots of good jobs. And so a little bit later, I worked on R, did projects for a while, and then I noticed one of the other local companies, State Farm, was hiring data scientists. And so I went and interviewed and, was one of the early data scientists on that team. We grew that team. I was about the third data scientist that joined, up to about what it is, about 25 people now. And so I did that for about 2.5 years there, and then just recently kind of moved over to Caterpillar. So
Nice.
Does that help answer your question?
Yeah, yeah. One thing that I found kind of interesting is you mentioned the war driving effort where you went around with the Wi-Fi devices. And I did something similar my first quarter in grad school. I took the sampling. I had to take the sampling and experimental design course. And my sampling design was trying to estimate the number of Wi-Fi access points on the UCLA campus. And this was 2007. So I had this little tablet, and it seemed really high tech. And I mean, now it's a little high tech, I guess. I had this little tablet, really slow tablet, with the Bluetooth and with the Python program on it. And all I did was I walked around. I did a sample, certain buildings by size, certain floors. I walked around late at night from like 8 to midnight, collecting and logging these access points and their GPS coordinates. So it was a pretty fun project, but it just reminded me of that when you mentioned that. I was able to get an estimate, but I know now, what is it now, 10 years later, it's probably 10 times as many access points.
Oh yeah. But for me, I think that kind of the process of having to, figure out a research question, kind of go out and not just, right, we're kind of used to in this day and age world, and we do this right in the course, we point people and say, go grab something from data.grub, go grab something from this. But really a lot of times, when you're dealing with kind of problems, you have to really kind of think about what's the best data for the problem. And sometimes you have to go out and create that data. You have to, and this happens in a business setting where you're just like, the data you have, is it good enough? If we want to understand this relationship, we need to go get data exactly on this point. So I think that's an important thing that comes out of that, is that you sometimes need to have those people walking around collecting the data, so then you could do further analysis on top of that.
Yeah, definitely. And, one thing that I try to encourage, so a lot of people, when they're taking this class, they're new to data science. Well, I can say a lot, most are new to data science that are taking the courses. And one thing that always comes up is, how do I pick a project and whatnot? And sometimes people will get the motivation or have the interest in scraping their own data. And I always encourage that, although it does require a certain technical hurdle to jump on. But it always seems to yield the best projects, because you have that intimate connection with your data once you've collected it yourself and whatnot.
Exactly.
I always encourage that, but sometimes it's practical, sometimes it's not.
The other good part about collecting your own data is you kind of realize that data has lots of holes in it and lots of assumptions in it that often, if you just use somebody else's data, you don't necessarily think about. But when you're the one that has to kind of put data, is it go in this category or does it go in this category? You realize that amorphous nature of data that is not necessarily perfect.
And you really get a sense for how messy data can be.
Exactly.
We encourage working with messy data sets.
Yes.
So one thing that you mentioned in your experience that I found interesting, and is also interesting for some mentees, because they get their PhD and then take this class, or their master's degree, or they just come out of academia, could even be with the undergrad degree, where they may not have worked in industry very much yet. What recommendations do you have for somebody who is coming out of academia or coming from an academic environment, moving into data science?
Yeah, so there's a couple of things there I can think about. So the one and the biggest and maybe the funniest, but it's also the delicate one, is often people with PhDs typically have a bad reputation for joining data science teams within business and industry. Because when you get a PhD, right, I mean, part of the way it works is you have to become an expert at one narrow piece, right? You are the person on this field that, right, everybody should look to you on this. And sometimes people carry that same attitude and expertise and assume everybody else around them understands the computer side, the data side, the math side, just as the high level as they do. Because that's what often happens, right? When you're in grad school with other PhDs, your peers are like that. And so when you go into like a business setting where people come with lots of different backgrounds, are maybe not that interested in the technical side, sometimes with the PhD, you have to learn how to kind of tone it down a little bit and address kind of a broader audience and be able to kind of talk to other people that might not have that same level. So I can tell you that's one real life issue sometimes with people that have kind of advanced degrees is being able to make sure they have the soft skills to be able to transfer and work with that, right? The advantage having the master's and the PhD is that you've probably worked on a problem in depth, in detail, and so you can kind of call on that and show employers that, look, I can dig into a problem. I know how to do this. I'm self-motivated, right? Nobody sat over me the entire time I was getting a master's. I had to, show up and do all that work, and, you could show them something that you've done. So that's kind of the good parts about it. And I'll say, right now there is a little bit of snobbery in terms of, right, if you have a master's degree or a PhD degree, it's a little bit easier to kind of land a data science job. Sometimes positions will just say, we want only people with advanced degrees.
Yeah, that's really interesting. I'm finishing my PhD next month as my defense. I was fortunate enough to work. I took a break and worked for a little while, so I'm hoping to avoid that whole challenge. And I'm kind of low key anyway, so I'm not one of those people that tries to talk in all fancy language and whatnot. But that's a really good advice for anybody who is coming out of a PhD. So Lana Lana and Jay Cardenas have a question. Lana, I'll definitely come back to yours. The next one is very much related to what we just talked about, and you kind of answered it. His question is, or her question is, what was your main challenge going from academia professor to industry, and did you have to learn new tools?
So I think the challenge is, again, around kind of the soft skills and the expectations, right? So, depending on the size of business or industry, kind of corporation or whatever you go to, right? If you're in a big Fortune 500 company, you have a bureaucracy to deal with, right? Where you have people have different agendas and different things they have to do, and you have to navigate all that. It's not just kind of like a little lab environment where you can kind of just download whatever you want and just go at it, right? There might be specific rules around what type of tool and software you're supposed to use, who you're supposed to contact. If you want to present something, you might have to go talk to a PR person before you do it, right? If you want to move data from one server to another server, there might be people in governance you have to talk to. The IT admins might not give you root on the server, even though you wanted to be able to do things, right? So there's realistic kind of challenges from kind of being your own, kind of working on your own, to working inside a large company. But also the other big piece there is understanding the business context, I think, is really important. And you don't necessarily get used to that in academia, where people are interested in how the problem affects the bottom line. They're not interested in the intellectual excitement you find in it, or that you're covering a new algorithm or you get to use a new technique. They want to know, are you going to be able to solve this problem in a timely manner for me? And just kind of have to being able to shift and think along those ways is kind of sometimes takes a little bit.
What's interesting is everything you just mentioned was every problem that I faced in my very first position.
Nice.
Not being able to get sudo access, having to go with PR, and I was a little bit of a renegade. Like, why do I really have to do this? So, it was a good experience, and obviously I'm more mature now, but it was tough for a while. Now I get it. That is a big, big problem.
Yeah. So when I worked at State Farm, since they're in their insurance, but they also have a bank. And so because they have a bank, they're very highly regulated. Yeah. So for example, when you're using their computers inside their network, you can't go to Gmail. So like everybody has Gmail, like you're used to just checking it on your work computer. While you can't do it. You can't go to Dropbox. You can't go to Evernote, right? There's huge amounts of the internet that are off limits to you. And so it becomes a real burden. I mean, there's special rules around open source software. Like there's some packages you're allowed to use, some you're not. So no, and you'll never get access to servers and things like that in a very highly regulated environment like that.
Yeah.
So, and it can take you so when you go to new tools, for example, when you're inside a corporation, it can take 6 months at minimum for the procurement process to go through to buy something that costs $1,000. It's just, that's how these companies work. They're so risk averse. They have lawyers that negotiate everything. It's hard to get anything done like that. That's kind of the nice thing about open source, because you can quickly download those tools and get them going. But I didn't specifically have to learn any new tools. I think one of the big differences, though, that you have, excuse me, in businesses is that you really have true big data. When I was in academia, we had some data, but we just didn't have the resources. Weren't able to have our own Hadoop cluster, for example, that was really large. I'm sure some institutions have that now, but I think one of the differences is when you get to those kind of corporate environments is that they just have a lot more resources, and with those resources come the latest and greatest tools that you have to kind of adapt and learn how to use. That things like when I talk to people about using Hadoop tools and data scientists and stuff, the advice I give is just understand the terms, maybe play around a quick little demo like that, but you're not really going to get the same experience or same knowledge, running it on your home environment or trying to fire up a little cluster on AWS as in an enterprise. And it's just, that's the reality of it is once that. But what you want to show is that you have some idea of what that is and that you're capable of learning that stuff.
Mm-hmm. Yes, there's a lot, and I try to encourage people to learn. I recently spoke at our UCLA Stats Club last night, and I feel like I'm coming back with this wealth of knowledge after working in industry that a lot of professors aren't able to help them with. And I told them, I said, you need to learn how to code. So everybody else on the panel was saying, you need to take a bunch of math classes, you need to do a bunch of research to learn how to code. It'll help you in grad school. You may want to, before you get an internship, you may want to play around with AWS or Hadoop or something. Little things that aren't taught in school. So that's a pretty common thread. I want to jump back to Lana's question, who asked, what are some of the projects the data science team at Caterpillar is working on? And actually, if you can, I think I know what Caterpillar is. If you could also provide a little description of what Caterpillar is and does.
Yeah, so right, the Caterpillar builds those big bulldozers and earth-moving machines you have, right? So kind of mining equipment, construction equipment, they do that. So there's a lot of pieces to it. So one of the big kind of more interesting pieces, Caterpillar is working hand in hand with a company called Uptake. I don't know if people are familiar with it or not, right? And so that's doing like the cool, like fun stuff where you're taking telematics data from the engines, from the trains, kind of running it through prediction algorithms and say, hey, we can predict part failures before they actually fail, right? So that's like the really cool, fun stuff. And so Caterpillar is working hand in hand with the Uptake. There's also lots of other telematics projects at Caterpillar where kind of a lot of the machines we have sensors on them that will send back information so we can kind of monitor that. There's another piece of automated trucks. So Caterpillar was one of the first ones to actually have kind of automated vehicles out there. And in fact, what happened is Uber kind of stole, I think, a lot of our team actually, because I had a Carnegie Mellon and stuff. But so there's that piece of it, which is kind of the fun, interesting part for me with machines. But then there's also the traditional data science kind of things that you find in any corporation where you're going to start analyzing your internal data to see, what's the best way to recommend machines to dealers, right? How do you figure out what your best customers are, what they want, right? Those kinds of things. You have kind of internal things. You want to be able to assess performance of employees. I'm just kind of making a little bit of this up. I don't know all the projects, but internal projects where you might want to do something to assess which project teams are the best, for example. I work in kind of the global supply network division, and so mine is more around the supply chain. So the idea there is, right, we want to optimize supply chain, kind of reduce costs, figure out ways to do that.
And where is your team or the data science team centered in the company?
Yeah.
Engineering or part of marketing or?
So the way that it's structured right now, the kind of the analytics and innovation, I think they renamed it recently, is most of the data scientists are probably in the Peoria area in Illinois. There's also a Chicago office now, and they're hiring there as well. And then, those are the two main locations for kind of data scientists.
Awesome. Ajit has a question. Defining a problem statement or requirement. Is business or data science as well do that? Can you clarify your question a little bit? But I'll keep writing.
So basically defining a problem statement, requirement statement, is always business's responsibility, or data scientists as well come up with that?
Yeah, no, that's a good question. So, right, like, if as the data scientist, what's your responsibility for figuring out what the business problem is? And I'll tell you, kind of when you're new and junior, it's a little intimidating to do this stuff, and you're just like, I just want to crunch the data, dude. Don't get me too involved in the business, any of that stuff. But as you go further along, just like as we were talking about collecting the data, you're going to realize that really the earlier you can intervene in the process, the better outcome you'll have down the stream, because you know what data science can do and can't do. And sometimes people will come with you with a problem statement that's kind of impossible or that really misses the mark, where if you were involved in the decision making that problem statement earlier on, you could kind of steer it a little bit towards that. So I think as you get more experience and you get more comfortable, both, in terms of being a data scientist, but also understanding the business and what they're trying to do, then I think it's important to be involved in shaping those problem statements a little bit and talking to the customers and knowing exactly what they're looking for.
Yeah, so one question that we get asked a lot is, what is the difference between a junior data scientist and maybe a mid-level or senior data scientist? Mid-level kind of mixing the two. And I think you pretty much nailed it. A junior data scientist is usually going to be somebody who just wants to crunch the data. They probably do a little bit of working with clients as well. But as a senior data scientist, usually at most companies, that's going to be more into the business side. And when I started, I had no interest in the business side. And I think it's just something that came for me with age. Now I'm more interested in the business side, because that's how you make the company better. That's how you make the team better. So kind of going along with that, Jay Cardenas asked, what are the qualities that you look for in a new data scientist? And along those lines, what is more important, coding or math?
Yeah, so the biggest quality that I look for in a new data science is somebody that's really a passionate learner, somebody that just loves to dig in, learn something new, and is able to, totally master it and transfer it, explain it at a common level, right? That's what you really want, because data science is moving so fast that just because you're good at one thing, that doesn't really matter. It's what you're going to be, what the challenge I'm going to give you 2 years, 3 years ahead, that you're going to be able to catch up. You're going to stay with the field and know that. So that's the biggest thing. And so that's why I often like to look at what projects people have done when I'm interviewing them, to gain that sense of passion. And, did they have to go learn something to solve the problem? And if they did, how was that process for them for learning that? Because that's what I'm going to have people do is, the technology, everything changes every 2 years, right? So you need somebody that's going to be able to pick up that new stuff. And I think it's important, if you're thinking about a job, is showing that you've been able to pick up and learn something and master it. So, so what's more important, coding or the math? Of course, the easy answer is both are important, right? You need to understand kind of how the algorithm works. If you don't have the fundamental assumptions for how it's going to work, you're going to misapply it, and you're going to have bad results, right? And then coding is important just as well, right? Because you got to be able to write that thing up in a timely manner, in a neat manner that you can hand it off to someone else. Now, what I can suggest, though, is if you think your strengths are better in one area than the other, there's ways to kind of go in those directions. So if you're really good at coding, right, you can go towards a little bit of a data engineer side, a little bit saying, hey, this is my skill level. I'm, put me in these situations where I'm not writing new algorithms, but I'm helping to get these algorithms out the door really fast, right? While if you like the math, you like exploring the algorithms, right? You can look for a position where you can be like, look, what my specialty is I understand the math. I can squeeze the most out of these models, right? Because I can figure out how to get that extra, 1 or 2% more of performance, because I understand these algorithms and can restructure it in a way that really fits your data.
Mm-hmm. Yeah, it's an interesting teeter-totter. At Facebook, if you were better at the math than the coding, were on the official data science team. And their definition of the data science team is a little bit different than what everybody else's is. They were all PhDs, all research. They mainly wrote papers. pure extension of what it was, almost a postdoc for them, the pure of their PhD program. And they weren't the best coders, but the idea behind it was that they would get better at that. So if you're more into the math than the coding, something like that type of role, sort of a research role, I suppose, will probably fit your needs. And if you're more of the coding type, you may end up going into more of the engineering route. What was interesting in my career was that I liked computer science. I got a master's in it. But because of that, I've always gotten pigeonholed as an engineer now. And I kind of just have to live with it. It's not going to change. I have the degree. I can't tell them, you know what, I prefer to do more math than engineering. So I have to deal with that. But there is this kind of balance between the two. And I haven't been able to find the perfect split. But you just have to look around the job descriptions and whatnot to kind of figure out which one is more attuned to your abilities.
Yeah, and I have a feeling that it's a little bit harder to get the researchy jobs. That I think there's a lot fewer of them and a little bit kind of harder in terms of PhD. You want publications in the field, those sorts of things like that to do that. So if you really want to do that kind of thing, you're going to have to kind of do those things to kind of show that you really belong in that field. Yeah,
it's a little more rare to find the research position. It's going to be in a big company, and it's probably going to be, then they're probably going to require a master's or a PhD, even more so than a typical data science role. Lana says, in line with that, what are the roles that exist on your specific data science team? So data engineer, data scientist, project manager, etc.
Yeah, so, I mean, a little bit depends on the kind of the environment that you're in. I mean, and what your project is trying to do. So I've been on some teams where it's just, me and one or two other data scientists because we're just doing a proof of concept. We're not even, putting something out in production. I've been on other ones where the goal is to move something to production where the data scientist basically has kind of a consulting role there, but you've got a whole team around you of software developers, a project manager, and everything is very structured and you're moving through the process. So, I mean, there's lots of roles. I think the biggest thing is the difference kind of, and we kind of touched upon this, the different types of roles within data science, right? So we have those researchy kind of ones we talked about, right? The data engineers that are a little bit closer to the nuts and bolts of moving data around, as opposed to kind of the algorithms. And then you have nowadays, right, the data analysts in some places, those are considered data scientists, right, which might do more like reporting, kind of reporting with Tableau or running kind of SQL queries. And so that's right, kind of the data scientist light in some areas. Am I answering your question that way, or is there something else you're looking for?
Lana, you can either type in if you want some clarification. Okay, yes, perfect. So Lou, I really like this group. Usually it's people are very, very quiet. Takes a while, but this group, keep up the question. Lou has this one's a little tough. He completed the intensive course and got a job in a data science team as a data analyst. So that's always a good first step. But he's kind of in a niche where he's doing time series forecasting and only has an undergraduate degree in finance. And his question is, how do I transition from what he's doing, forecasting, to something more technical like deep learning, machine vision, and self-driving vehicles?
Okay, so there's a couple of paths to do, right? The one path is try to get your job to help you do it, right? So if there's people at your work that are doing something that you want to do, reach out to them and say, hey, this is what I want to do. Will you mentor me at least, right? Most people are flattered if you go to them for advice and are quite happy to kind of talk about themselves like I'm doing for a while, right? So, that's the easy thing is make sure you're on their radar. So that way they know if they're going to go higher, they need to fill a position that, wait a minute, Sally down the street here has already shown that she's interested in this topic. So that's the one big piece I have. The other thing, especially things with like deep learning, which are really hot right now, I think one of the things to kind of really get into the field is you kind of have to show that you can do it if you want to get a position straight into it. And so, this is why kind of a lot of kind of students with masters and PhDs in deep learning are hired, because they've kind of shown, they have papers, they have exhibits, they can kind of show that they've run some models and know how to apply this. And so if you want to do the same thing, I think it's the same kind of thing. I mean, so some people do, like the Udacity has a very popular course on, I don't know if it's on autonomous or self-driving cars or something like that, that's really hyped up. I think the traffic sign classification is a problem right now that lots of people are doing, and it's a great way to kind of build that skill level up. If that works for you, some people like the structured course. What I suggest is, if that doesn't work for you, go out and just run some projects, right? The great thing about things like deep learning and data science is the code is out there, right? You can go out and grab it, run it, kind of learn from it, and then take it and then make your own cool project. Find a way to modify it in some other interesting way, and then publish it out there and show people that, hey, this is what I can do. And this is often how I kind of, suggest to people, and kind of how I've often built my own resume and kind of list of projects is, if I'm in an interview or something, or a recruiter's going to look at me, I don't want to have to tell them that I know about something, or, I'd rather be able to say, here, I've done this. I can just show you, go to my repo, and you can see that I've actually done this. You don't have to listen to me talk about it. You can go and actually see my code and see that I've done it. Right. And so that's what I kind of suggest is if you really want to kind of go out and do it, just go out and do it. So there's, the internet's full of great resources for learning and doing this stuff.
Yeah, the deep learning thing is kind of tough. I try to avoid a lot of these things that have a ton of buzz. I think deep learning is going to continue, but originally it was just plain data science was the big buzz that everybody wanted to do. And what's tough about it is that it's difficult to really show that you're good at it without writing papers and doing research in it. So right now, for example, at Facebook, Jan LeCun runs the AI group there.
Mm-hmm.
All the people that work under him are people with PhDs that did research in neural networks and deep learning. They weren't people like me that are good at machine learning and data science, but weren't as familiar with that type of stuff yet. So I think my advice would be, if you want to go in the deep learning route, will be try it. Of course, try it, keep trying, get mentorship, work on projects. But also wait it out a little bit. So don't get too upset if things aren't working out. It's because right now it's just they're trying to hire all the senior experts to do this, apparently, because it's difficult to get into this without a lot of the research. So eventually they're going to end up hiring more junior people or people that aren't doing research, because not everybody's a researcher. And then that would be your opportunity, I think, to get into the deep learning, but always keep trying and whatnot. And I think you'll be surprised. I know an undergraduate who just got a job working for a deep learning company at a more junior level than a researcher. Which are the best?
Here, let me finish on the deep learning.
Yeah, sure.
The research side is really huge of deep learning. But I'll say there are some people that are big in the deep learning community that don't have PhDs. So you don't necessarily have to have that. Yeah. I mean, but you have to take the time to go in and understand. Right? It's a very sophisticated math. It's kind of hard to do computers. But also, I know it's the hot thing nowadays, but it's the hot thing nowadays, and I think it's first important to understand your regular traditional machine learning algorithm before you learn into that. You should have an idea of what a GLM is, how to use decision trees, right? All those kinds of basics you need to have before you really jump into deep learning into that. But I think, at some point soon here, I think deep learning is going to be one of those kind of filters that might kind of say which job candidates you want or don't want. So, it's another thing. I mean, it's a billion things to learn and stuff like that. But yeah, at some point, you should think about kind of doing it if you really want to kind of round up your resume.
Yeah, I completely agree. You don't need a PhD. It's just right now, it's a lot of stuff is up in the air. You can very well get a job now with it. That's kind of just how I kind of feel right now about deep learning. It's a little chaotic, but we'll get there. What are some of the best data science cities in the U.S. other than San Francisco, New York, and Seattle?
Oh, I don't know if I'm the best one on this. I mean, I'm stuck in Central Illinois, like that. So, I mean, I think you can just look at the number of jobs and things like that to see that. I mean, the great thing about data science is, yes, there's some big advantages if you're in San Francisco, New York City, in terms of having the amount of people in same physical proximity going to meetups and meeting things. But with the internet has been a great leveler like this. Like, for example, I use Twitter, right? All the deep learning people are out there on Twitter. They're sharing their information back and forth. People publish their papers and share their code. So, I mean, I guess if you're interested in kind of which city to get a job, that might be helpful like that. But if you're not in one of the top cities, I don't think, you should be too down on yourself in terms of learning data science.
Yeah, my kind of philosophy about that was I worked in LA for a while, and we have sort of a growing tech community out here. But I was pretty set on I need to move to the Bay Area, and you don't have to. It just depends on your personality. For me, I had to get it out of my system, so I moved up there. Now I'm pretty convinced after being there and seeing how expensive everything is. The work-life balance is non-existent. This is a career that you can really do anywhere, in the sense that everybody has these type of problems.
Yeah,
and maybe you'll have to move from this state to the next state over if you want a job, but you shouldn't have to move from Mississippi to the Bay Area to work in data science. But some cities that are really coming up, Austin, so really it's the same as the tech area.
Yeah.
Austin is one that's really coming up for data science. They have a lot of companies there. Boulder, Colorado, interestingly, is another one. Don't know a whole lot about that. Portland, of course, that's also an area. Those are kind of the main ones that I can think of off the top of my head. But there's a lot of other ones. There's somewhere in the Midwest, surprisingly, that is escaping my mind. Well, Chicago. It's aside from Chicago, but there's one in the Midwest. I want to say it's in Kansas or Nebraska or Oklahoma, but it's not coming to me. So yeah, I mean, it's all up to what you want to do. I would encourage you, if you're just getting out of school and you think you need to move somewhere, try it, see how it goes. You can always leave and then, set up your own thing or find a company that's local to you. That's what I did.
Yeah.
Okay, this is our usual reminder. I usually have to say this every 5 minutes, but this has been a great group. If you have any questions, type them in. We still have plenty of time remaining. Otherwise, I'll start going off on some of the questions that I usually ask. What's one thing that you wish you knew when you got into data science or became a data scientist?
Wish I'd known, or what was the question again?
Yeah, what's one thing you wish you knew? Like something that you got into the field and like, wow, I wish I would have learned this before I became a data scientist, or something of that nature.
I'll tell you, I think one mistake I think I made early on that I've kind of tried to do it is I'm trying to figure out the best way to say this. Is sometimes you get caught up in the hype and the names and just trying to learn kind of what every technology is about. Like, making sure you understand what Kafka is Mesos is, all that kind of stuff. And you kind of miss out on some of the fundamentals. I think at one point I was kind of so into big data. I knew all the big data and stuff, but somebody asked me a question about random forests, and like something very simple, like, how do you figure out the number of variables that each tree has in a random forest? And I was like, I don't know that. And it kind of forced me to go back and make sure I really understand the fundamentals. And so I think, as a real practicing data scientist that really has to work, I think you want to stay close to understanding how those simple algorithms work and having a good sense of that. And also, don't spend too much time reading stuff. Spend time coding. I mean, it's easy, right? It feels good to, like, you read a new article, you read a blog post about how to do something like that, but you'll learn something 10 times better if you actually code it out. And one thing is to code somebody else's example and kind of run through their notebook, but it's even better to try to find something a little bit different and apply it to that, where then you're going to own it. It's going to be yours because you figured it out, and it's going to be a pain in the butt, and you're going to get stuck on stupid stuff, but you're going to become a much better data scientist at the end of the day.
That's really helpful for me as well, because so when I was early on in grad school, I had a lot of free time. And so I did that. I read about all of these different packages, and I went into some internship interviews.
Yeah.
I didn't have the best solids knowledge on machine learning, but I could list off all these packages. And so that, of course, obviously didn't work out too well at the time. And then I went to Facebook, where I really didn't have very much time to do any outside learning anymore, unfortunately, which is one of the reasons why I left. But after that, I started getting down on myself. Like, I'm not reading a lot. I'm still learning. I'm doing a lot of coding. So what you just said actually makes me feel a lot better, because I feel like I am doing I'm doing data science, doing data science, but just not doing as much reading and hype over packages as much as I used to. I need to get better with Spark, though.
Yeah, I mean, data science is a fire hose of information, in terms of everything new that's coming out, the deep learning, all this kind of stuff, that if you try to absorb it all, you just can't. And so it's better to just kind of accept that you're not going to be able to stay on top of every new package, every new development. Just that's why I encourage people to be part of a larger community where people will be like, I know you're working on this. I think this might be useful to you. So that way you don't have to learn everything, but you can kind of rely on a little community to help you out and kind of keep you up to date. And so that way, if anything really big comes out, somebody will tell you about it. You don't have to worry about kind of catching everything.
Do I need, or do we need, the royal we, do we need a peer-reviewed publication to demonstrate my skills? Or is a good quality GitHub repo enough?
So it really depends on what you're trying to do, right? So, peer-reviewed publications are great if you're an academic, right? If you want to get tenure someplace, you need those peer-reviewed publications, right? Those peer-reviewed publications can also be really helpful if people are looking for that pedigree when they're hiring you, right? So some, like, for example, like high finance firms, sometimes say we only want a PhD that has, publications in this field. And so, yeah, if you want that kind of job, you're going to need that. But if you're not in academia and if you're not planning to get tenure, it's probably not that important to have a peer-reviewed publication to show the skills. Especially, I think nowadays, it's much better, instead of having a peer-reviewed publication, is to put out a package that's really popular, right? If you can get a package that adds some value to the open source community, where you're at the point where there's actually people that are contributing back, that there's other people that have committed to it, that shows that there's that much value in it. I think that's, often much more important and much more valuable, that you've done something entirely new, that instead of a peer-reviewed publication, which like 3 people might read, right? You've created a repo, right? Where there's, 100 people that have started, and you've got, 10 other people that are willing to kind of spend their own free time contributing to it. So I think, there's other ways to kind of demonstrate your skills. I mean, I think, doing high quality blog posts is another one, right? Every week you can find a couple of new people that have written some really cool, awesome blog posts. I think that gets people a lot of attention, and it's also very valuable to the rest of the community. So
I spent so even though I'm getting a PhD, my goal is to go into industry, maybe teach, but not go the full tenure track and publish out my ears. But what I focused on was, instead of publish or perish, was Twitter, which of course I can't really write very much on Twitter, but Twitter, blogging, creating presentations for meetups, all that type of stuff. So if you are kind of in a graduate program and you don't want to go the professorial route, you can do your publish or perish in other ways. With blog posts, giving talks at meetups. I'm finding that it's really helpful now. My department just started this professional master's in statistics, and the people that are teaching the class, while they do a lot of interesting research, they haven't worked much, if at all, in industry. So I'm actually giving them a lot of slides that I've prepared about big data and R, all the things that the students are asking for. So it's very, very important to have a balance of both the research grad student, but also the more industrial and/or non-publishing. That's not the right word, but not a focus on publishing aside from the discipline itself.
Yeah. No, that's good.
Let's see. What else? What else do I usually have on my list? We've covered a lot of it, actually. What might you do differently? Let's say you were going back into you were making the decision to become a data scientist again. What would you do differently?
It's a good question. And I don't know, because partly I've kind of fell into the field and kind of just adapted it as it is. It's not like I came in with a lot of, preconceptions. I mean, I think, one of the things, if I had to go back in time and if I could fix about myself, is I would improve my math skills and have, a stronger statistical background. I mean, I did all that stuff, but I did that a long time ago in school, and so it's not as fresh with me. And at the time, like when I studied linear algebra and matrices, I mean, there really wasn't a lot of, there wasn't anything like neural networks where you were using them. So, I mean, we kind of just rolled our eyes and we did it, and we didn't see the practical applications for it and stuff. And so I didn't, necessarily kind of understand every piece of that as eigenvectors and all that stuff, as maybe now when I appreciate that mathematics and statistics a lot more, because I'm building off of it. So I think, that's one thing, if I had to kind of fix, I do that. But on the other hand, right, my coding skills could also use some development too. So probably, yeah, I got lots of holes.
Well, we're known to be hard on ourselves. Data scientists, and software engineers, it seems. Is job experience or education more important to your company?
Job experience or education. So I'll tell you, there's usually a bright line between people who have a master's or a PhD versus having an undergraduate, right? In terms of when we're looking kind of at people. Now, if you have done something else besides the undergraduate, like something like a Springboard, or you've done Coursera or something like that, that kind of helps a little bit. Like that. But, this is what we always kind of used to say as a professor for grades and things like that, is right. The grades are just, they're really only important for getting that first job, because after you get the first job, nobody else is going to care about the grades you got in school. So, I mean, at the end of the day, yes, having those, that's important. But if you're on a team where you're doing experience, where you can get experience doing data science, where you're applying it, I mean, that can be much more valuable in the long run than maybe the master's, because you can say, hey, I've coded in this, I've done problems like this, I've solved pieces of like this for actual, businesses that were paying me money, that cared about the quality of my code, not just some kind of, professor that's doing some, throwaway experiment. Mm-hmm. So I think, having that practical experience, especially, that's why I push, is if you can get that practical experience on the workplace, even if you kind of volunteer and say, you'll just do a couple extra hours on your own time, or, you'll just shadow, whatever you can do to kind of get in, that is, I think, really important.
This next one's a little tough, and I've actually gotten this one from a couple of mentees. For those of us who don't have much formal education, how would you say we should write our LinkedIns to stand out? And a little bit of background on this, at least in my case, of some mentees I've worked with, they have a lot of work. They typically have a lot of work experience, and have impressively moved into the data field without maybe even having a college degree, and now eventually want to make the leap into data science. Mm-hmm. And I have my answer that I usually give. I'd be fascinated to hear what your thoughts are on that.
So transitioning from having lots of experience into data science without kind of doing some kind of college experience is what you're asking?
Lou, did I kind of steal your...
Am I getting it right?
Kind of correct what you're asking.
Can you guys hear me?
Yes.
Yeah, so it's not necessarily without a college education.
Oh,
but
okay.
The situation that I'm coming from is so I did my undergrad in finance, which is kind of quantity, and kind of set me up with the prereqs that I needed. But I don't have a master's or a PhD or anything like that. What I'm doing right now is I'm taking some graduate courses at Virginia Tech at their graduate school of computer science. And I'm wondering how I can best kind of display that on my LinkedIn, or combine that with my job experience to make a profile that would be, competitive for large tech firms or, competitive data science jobs.
Thanks for clarifying.
Yeah, I'm not a kind of the recruiter that kind of goes through all the LinkedIn profiles, so I don't know if I can totally hit that, but what my recommendation to is first is, especially with people with lots of experience, is find a way to piggyback off that when you're kind of positioning yourself as a data scientist. I mean, if you spent years in a specific industry, right, you can use that knowledge and say, I'm an expert in this, and I can bring that to the table as a data scientist. If you've had specific skills, same way with specific skills, right? Because I think having that past experience, even if it's just, I know how an organization works, I know how to get stuff through a company, I think you want to make sure you can emphasize that piece of it. On the data science part of it, I think the big thing, I think you just want to show is that you've been able to learn the material and you can apply it. I mean, this is why I kind of look to having things like projects or GitHub repos that you can kind of point to show that you've, not only got a certification from some program, but that you've been able to apply it in these ways. Lots of times I'll see on people's resumes where they'll put the cert, but then they'll put one or two little mini projects that they've done as a data scientist. So that kind of clues me into, this person has already played around with text analytics, or this person has done, this kind of problem a little bit.
Yeah, that's definitely helpful. And I considered putting some of my work on my GitHub, but the thing is, I think stuff that I do within my company is their proprietary code. So I'm not sure if. Yeah. And so that's often a tricky case with the proprietary code and stuff, because technically, right, if you're doing something for the company, it's kind of their ideas for it. So this is the kind of the way I get around it a little bit, is a lot of times if you're doing something proprietary, there's something that's very similar to it that isn't proprietary, right? Where usually the proprietary is just taking a twist off something that's out there existing. So what I do often is go back to that existing code and make sure you kind of know how that works, and maybe, contribute back to that GitHub repo with some type of comment, or, use that public kind of example in your GitHub and not the proprietary one. Does that make sense? Just so you can show that you've mastered this technology and you understand how this approach works. Right. Yeah, that's a really good idea. So
and then when in an interview you can say, yes, I know this is approach, but actually, in my company we changed it a little bit and we did this, where you can kind of show that you've mastered it and did it in a particular way without kind of spilling the secrets of how you did everything.
Gotcha. Okay. So, thank you very much. Appreciate it.
No, and I encourage everybody to kind of do that. Is when you do stuff at work, find ways to transfer it out, because most of us nowadays are in this kind of world where you're not going to work for the same company for 30 years, and you need to kind of keep building yourself, keep showing how you're creating values, that you're learning things. So find, pieces that you can do and demonstrate without kind of selling the company up the river on what you're doing. So
that's really good advice. Let's say you learn the fundamentals but have never worked with big data. How important is the big data hype to career growth in the data science industry?
Well, so it's another one of these things, just kind of like the deep learning, is sometimes it's kind of used as a filter to figure out, which people to interview or something. So you should always put big data on your resume, and you should have some understanding of a couple of the words, to do that with. But, you're not going to be able to do that kind of the big data stuff outside of a place where you can have that. Can you give me the question one more time? I think there was a piece of it that I didn't hit that I wanted to hit.
Let's say you have the fundamentals. So but I've never worked with big data. How important is the big data hype for career growth? So I think one aspect of this is, say somebody comes out of a graduate program or even undergraduate, and they know all the math. They can do all the math, and they can code it all well. But obviously in academia, you really don't have access to Hadoop or Spark equally. And Lana, if I'm totally wrong, feel free to either type or get on your mic and clarify.
So I think, part of it is if you look at most data science work, my guess is 90% of data science work is, smaller data. It's not necessarily using big data across a Hadoop cluster. And so there's a small piece of that for kind of data scientists, right? If you're more of a data engineer role, then that big data comes into a bigger play, because that's kind of where most of those positions are. But even the data scientists, within companies like a Caterpillar and State Farm, very few of them work on, most of us maybe have one or two projects that touch kind of big data. I mean, there's not a lot of us kind of doing big data full time. So again, I think it's just important to kind of have a general idea of what it is, maybe what the challenges would be, but I wouldn't kind of worry about it too badly if you haven't had that.
Yeah, usually, as long as it's not a startup, usually companies will train. Well, that's maybe too formal of a word. They'll let you learn on the job how to use Hadoop, for example. What you do want to know, though, is, for example, what MapReduce is, what is the mapper phase, what does the reducer phase do, and at least be able to describe it. If not, practice coding it or whatnot.
Yeah.
You can practice MapReduce in a language like ML or Lisp or something. That's where it comes from. So just understand those constructs. You don't have to build it up yourself or find a 10 terabyte data set to work with. Just understand the basics.
Yeah, I mean, I tell people just spend an afternoon or so and kind of learn a little bit about the general kind of things just so you can talk the language about it. But I wouldn't spend too much time about it until someone's actually paying you. So
we may have time for one more quick question. So if anybody, so at this stage, it might take too long to type out. So if anybody has a quick question that they want to get on a mic for, or raise their hand or through the system or whatnot, go ahead and chime in. Oh, okay. Well, we're about out of time. So let's all thank virtually Rajiv for being here with us today and for giving some excellent answers and advice on pursuing a career in data science. Let's see, what else do I want to say? Rajiv is a mentor, so you'll be able to contact him through the community if you have any other questions. We do this type of session once a month typically, and it's the only session we do about 60 minutes long to give enough time for you to ask questions and have a little more free-form conversation. Otherwise, thank you so much for joining us. Thank you all of you for participating so much and having such great questions. Let's keep up this great energy. It was a blast today. Have a great weekend, everybody, and we'll see you all next week.
Great. Thanks for having me.
Thank you.